Welcome to a new show of the Urban Wall Street Project. I'm your host, Earl Christian III, of course. I know it's been a minute, but sometimes you got to take that break and come back real strong. And strong is how we're doing it. In the studio tonight, I have an amazing gentleman. He's a brother, a colleague of mine from Howard University. You know we're representing always, but he's an engineer, telecommunications systems engineer. So for my people out there that want to get into that field, have an affinity for telecommunications or the engineering industry, you're definitely going to get your pens and pads out because it's about to be real serious. Engineering 101 with my colleague, Mr. Clarence Nurse. Clarence, how are you, brother?
What's up, Earl? I'm doing great.
It's
doing great.
Good, man.
So glad to be here, man.
Finally, we're making it happen.
Finally.
Engineering,
That's
HU
right.
is a beautiful thing. Just came back from homecoming. Wish you were there.
I
But,
know.
you know.
I'll catch the next one.
For sure.
You know?
But engineering, you know, I remember being at Howard, you know, and just knowing that engineering was a serious field. Never saw engineering students. They were always down really getting it in, and justifiably so, because at the end of the day, the dividends pay off for all the hard work. But I really want to get into it, and because you are the engineer, I want to talk about the different types of engineers there are, and recognizing that, according to President Obama, over the next 3 to 5 years, 80% of the job occupations being created are math and science. So I'm sure engineering is definitely going to become even more burgeoning than it probably has been in the past few years, but you can also enlighten me. So engineering, what is engineering?
What is engineering, man? Engineering is vast, right? First off, there's a bunch of different disciplines, right? I mean, you got electrical engineering, you got civil engineering, you got mechanical engineering, computer systems engineering, and it's all about the design of different systems, if you will, right? So I'm an electrical engineer by trade. At Howard University, studied electrical engineering, you know, down at the Hill. I hit some of the parties, but, you know, I was up late at night every night studying. It was all about math. It was all about science and everything, and my concentration was electrical, and then I ventured into telecommunications systems engineer. But before I talk a little bit about telecommunications systems engineering and what I do, let me just give you a little breakdown of some of the other disciplines within the engineering field in general, right? So you talk about, let's start off mechanical engineering, right? Mechanical engineers do things like build planes, right? You know, one of the disciplines under mechanical engineering is aerospace engineering, right? You know, the design of these engines and things of that nature, right? Anything mechanical, right? I mean, you think about a fax machine, right? Anything mechanical, right? Mechanical engineering, design of something in that fashion. You think about civil engineering, and we've all heard about, you know, Katrina and the levees breaking and all this kind of thing. Definitely. Army Corps of Engineers, they do civil engineering. So civil engineering, right? They build bridges, tunnels, levee systems, you know, that type of thing, right? So when you look at the Brooklyn Bridge, or you look at the construction of the Holland Tunnel, you know, that's all civil engineering at work, right? Still foundation math and science, but then you break out into your particular discipline. Okay. Then you got power engineering, right? When you think about power plants and distribution of power across the country, you know, it's another area of engineering where you're designing these systems in order to power everyone's home, right? I mean, you got nuclear power, right? You got natural power now, wind turbines, this, that, and the other. A lot of disciplines, right? You know, within that realm. Then you have computer systems engineering, right? The design of computer systems, okay, right? You think about, you know, how does a computer work, right? Somebody had to design that.
We were talking about that.
You
like,
know what I mean?
You
know, what's that? You know, so you got the design of the computer itself, and then, you know, what I do, telecommunications system engineering. I branched off into that because I was into telecommunications, right? It's all about sending information from one point to another, right? And the whole internet is built on that foundation, right? You know, when you think about the internet, people are like, well, what is really the internet? You know, people go online, they Twitter, they Facebook, they have their websites, everybody has a MySpace. Yeah, you're clicking around, but what is it? What's on the back end enabling that whole situation? You know, what is it? So, I mean, it all started from a bunch of universities that really needed to communicate research information between each other, right? They had computer systems that had a lot of data. They wanted to share that information. So they developed protocols, if you will, that allowed them to send that information from one computer to another computer. And then all of a sudden you had some smart guys at the University of Illinois that said, you know what? It would be nice if we had a easy way to access that information and share that information. So they came up with the modern day web browser. Right, you know, back then it was called Mosaic. Right, and these guys, college students, you know, they came up with a way where you can front end all that information with something easy to use, where you just click and move, and you know, basically something that everyone can understand and make it happen. That's where it all started. Then it just blew up. I mean, we know it blew up, right? It's crazy. I mean, you know, everybody has a website. Every individual has a website. When I first started messing around, you know, a few companies had a website, this, that, and the other. But now everybody has a website. It's crazy. So now what you have is, you know, each individual with their own information, or now companies with their own information. They have their own computer systems, and those computer systems run on what we call a local area network.
Okay.
You know, what's a local area network? Basically, it's just a network of computers, if you will. But what's making those computers talk to each other, right? In order to make these computers talk, what you have is routers and switches.
Okay.
So I work for Cisco Systems, right? The largest internet provider, internet equipment provider in the world.
Okay.
Right? And basically, the core business of Cisco Systems is the manufacture of routers and switches. Okay. So basically, moving all this traffic from one place to another, all this computer traffic. Okay. So when you talk about these local area networks have to connect to wide area networks, right? So in order for one computer system to talk to another computer system around the world, you need a wide area network, larger routers and switches to send all that information back and forth. Okay.
Now I'm listening to all of this, and I'm just
It's a
trying to
little crazy,
imagine,
right?
It's a beautiful thing. We're gonna go down and break it down
We'll
and
break
get
it down.
fundamental. But
Yeah.
I just had to sidebar this.
Yeah.
Where would the world be without engineering?
I mean, engineering goes back to, I mean, obviously the start of time, right? So there would be no civilization, right? I mean, when you talk about the design of systems, I mean,
Right.
it goes to the basic level of someone trying to build a tool to kill for food, right? I mean, so it's the underpinnings of civilization, engineering, right?
Exactly.
You know, and but then you just have different disciplines. You know, we just happen to be nowadays talking about a more technical aspect of engineering, electrical engineering, telecommunications system engineering, and the engineering of the internet, and taking advantage of that vast communications network, so you can, you know, spread your show across the globe.
Exactly. I
You know,
appreciate,
things like that.
what you do.
Right.
Now,
right.
I remember it's happy to learn the different disciplines because,
Right.
you know, when I was at Howard, it seemed like the main ones you always heard with either electrical engineering,
Right.
chemical engineering,
Chemical engineering is
and then
another.
civil engineering. Those
Civil
are,
engineering,
those are the
right.
main three, I guess, that, you know, maybe everything else is, that I remember.
Yeah.
You know, but you learn now.
Right.
Is there a main one that, you know, think people probably flock towards more or focus towards more?
Well, I'd probably say electrical engineering because so many disciplines stem from electrical engineering, right? You know, I mentioned telecommunications system engineering, you know, power, you know, systems engineering, anything with electrical components, if you will. You know, there's a foundation in electrical engineering.
Right.
And when you're in college, right, the first couple of years, you're just doing math and science, right?
Right.
You don't
That's what
really
I wanna talk
branch
about.
out into your particular discipline, electrical, mechanical, chemical, whatever, civil, to those last 2 years or 3, you know, in certain cases, right? So there's options to, you know, really fill things out and see what, you know, what interests you when you look at it from that perspective, right?
Okay.
So
looking at, you know, the sign of the times where we are, everything is everything is all technology.
Right.
And it's growing even more.
Right.
Where do you see as far as engineering, how is it going to affect or impact, I should say, you know, as we move forward? Like I said earlier, Barack Obama, the president, said 80% of the jobs are going to be science and math occupations. So what would be some, I guess, suggestions you might want to give to the generation that's coming up that think they're interested in engineering? And you know, give us a kind of maybe an overview of, you know, how you see the world over the next 5 years with the different, how should I say, disciplines.
Yeah. So the way I see it evolving, if you will, I mean, everything is going to be based in engineering concepts these days, right? All your jobs, because today it's all about being efficient, being productive.
Okay.
You know, how do you do that? And how do you be more green, right? So in order to do that, and these are all big initiatives that, you know, Obama has talked about, you have to understand these disciplines, right? I mean, just talk about being green, right? And leveraging wind and solar power, this, that, and the other, right? I mean, the design of those systems is going to be a huge field. Right, it's inevitable. Right. I mean, we're trying to, you know, remove our dependency on oil and things of that nature. Right. Well, how are we going to do that? We have to develop skills, right?
Yes.
Leveraging, you know, a background in engineering in order to design and develop, you know, these new tools. You know, that's just one example. When you talk about the more technical stuff and telecommunications and how businesses are more productive and doing more with less, you know, that kind of comes into some of the stuff that I do. Right. Telecommunications system engineering. Some of the things that we do is we show companies how to be efficient in terms of how they communicate within their own organization, right? There used to be a notion of a data network that just was leveraged for all the computers to talk to each other, and then you had a separate phone network or telephone network where all the phones were connected to. But now what we're doing is combining the two onto a single network, a data network, right, and leveraging what we call the Internet Protocol, IP. You probably hear the term IP, right? And we're putting all traffic on that network, right? And we're showing companies, how to do that efficiently, and so that they could, take advantage of all these new products and innovations that are coming out, right? So being in the forefront of that, requires a foundation in engineering, right? I mean, just understanding. Okay, I got a data network that's typically used to send emails.
Right.
Now I want to put a telephone conversation on that. Well, when I'm talking on the telephone, that information has to be sent in real time. Boom, 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 right? I mean, data, you send an email, if it gets there in 10 seconds, that's not a big deal. But if I'm talking to you on the phone, 10 seconds, that's an eternity. It's not acceptable.
Exactly.
So you have to engineer the network so that, okay, if we're leveraging the same underlying IP network, that the voice gets prioritized, right? Over top of those emails and files being exchanged, this, that, and the other. That's a discipline, right? And there are protocols and things to understand underneath that that allow you to do that, right? So we call that like quality of service, right?
Okay.
So that's just part of networking, data, IP networking, if you will, because we're putting voice over the same network, we're putting video over the same network, we're doing high definition video communications, amongst organizations where, just like we're talking right here, you could be in India, I'm in New York City, just this clear, real time. Over that same network, right, that was used to send those emails and this, that, and the other, and the same network that's used to send those telephone calls back and forth, but we got to optimize it and make sure we put the right quality of service on the different traffic streams in order to make it happen, right? So that's a discipline. That's all data networking, this, that, and the other, right? And that's the future, right? Because there's going to be a consolidation of these networks, if you will, right? So why not, consult, right, with companies? I mean, that's another avenue. I work for Cisco. I enjoy it. It's a great job, and I do that for large companies. But having those skills, you can do that on the side for small companies, right? I mean, there's other avenues and different ways to apply that knowledge with that foundation, in engineering. And in fact, I mean, you don't even necessarily have to major in engineering, right, to do some of that stuff. I work with some really smart cats that come from, other backgrounds, maybe just mathematics, or whatever. But, you continually reskill yourself. That's the thing folks have to realize, in any discipline, and you've talked to many people, they're always reskilling. If you're a lawyer, you got to continually read, stay up to date on the new laws that are being passed, this, that, and the other. Same thing with engineering, right? I mean, there's new things coming out, and especially for me, we have new products, this, that, and the other coming out. I'm constantly in a learning mode, right? It's not as intense as when I was in college, right? Staying up late every night, studying for tests, this, that, and the other.
And that's what we're going to go to, because, it's about that educating. Now, obviously, this is your passion. I can hear it. But there's a lot of knowledge that you've acquired over the years that we've left Howard. I'm not going to say it. People know how long that's been, but I don't got to go there. But what I'm saying is, I don't think, some things are jobs, some things are careers. And engineering clearly is a career and it's something that you have to have a passion for, because it's not like, I think I'm going to be an engineer now. When did you know, what I want to talk about, Clarence, is when did you realize, you had an affinity for that industry, whether before college, and then what, steps did you take, at the undergraduate level, and then post-college, to get to this point? I'm talking about whether it's internships, what are some of the things you would do? Because I want to let other individuals who may be going into college in engineering, currently an engineering student, or maybe they want to change their career in the midlife and they want to go into engineering and get back to school. I want to kind of give them some good, solid advice from that beginning to end stretch. How'd you know?
Well, for me, it was more so just wanting to know how things work, right? I mean, as a little kid, just, okay, what's this radio? How does it work? Break it open to see what's going on.
So you always
just kind of gadget type guy, and that kind of interests me. And then I tell you, one day I read a magazine and I was looking at the salaries, right? And electrical engineering was right up there, right? The engineering field. I was like, okay, wow. So let me figure out what's that all about? And it was all about everything I thought when I talked to older folks. Math and science. I was naturally good at math. I was like, okay, this is pretty good. Science interests me, and then you marry that with gadgets and wanting to know how things work. It was pretty obvious that electrical engineering, for me, was the way to go, and the electrical discipline specifically because of electrical gadgets, this, that, and the other, right? So that's early on where I got, the notion to do electrical engineering. So, just regular high school student doing my math and science. I did well. I didn't excel in high school, but I did well, right? I was one of them.
Any robotic? competitions? Did you
I
get
didn't. No, I didn't do any of that. You know, but back then, you know, we started with some programming contests. You know, I remember doing some in class. We had some programming, you know, challenges, if you will. We were using, you know, I don't want to date myself, but you know, using some of the early on, you know, programming languages and whatnot, and that was fun, if you will. But it was always clear, you know, and at the top of my mind was always that salary. I mean, you know, let's keep it plain, right? I mean, just the salary was there. And, you know, you look at doctors, you look at lawyers, and, you know, it's all great. It was lovely, but you gotta want to do it, right? And have an interest in it, right? So electrical engineering seemed to be a best fit, right? And, you know, lucky enough to have a buddy of mine that went to Howard, you know, in high school, and he was a couple years ahead of me, went down to visit Howard, and, you know, realized they had an engineering program. I mean, he fell in love with the campus, right? I mean, we could do another show just on Howard and campus, right? That's another segment. But, you know, I did due diligence and checked out a couple schools, you know, and Howard just blew me away in terms of just other young people that were serious. You know, I mean, in high school, sometimes I was the only guy with a backpack, you know, even thinking about doing some homework. You know what I mean? And I mean, that was just the type of environment. It was there if you wanted it. You know, and but most people really didn't take advantage of it, just kind of hanging out and doing whatever, right? So to go to Howard and see people like you and me, you know, very serious and wanting to do something with themselves, I mean, that was huge, right? So that just propelled it to a whole nother level, you know, in terms of motivation and studying and everything. And you know, math is very important, right? And to young people out there, I'd say, you know, if you're good at math, right, and you enjoy science, right, you know, I mean, that's the first step, and that's the big thing. And I didn't have calculus in high school, right? You think, whoa, what is this? But a lot, you know, a lot of people have calculus in high school, and calculus is really like the first building block of anything engineering, right? You got to get with calculus, and a lot of people have it in high school.
So if calculus it troubles you, then engineering is probably not the path you want to go into?
I'm not going to say that necessarily, because it troubled me,
right?
You know, and part of it was because I didn't have it in high school. I'm like, why didn't I have calculus in high school? Well, because I didn't have algebra in junior high or whatever. You know, you can trace it all the way back, but, you know, whatever.
So you suggest definitely if you think you want to go into engineering in college, definitely take calculus in high school.
Try to take calculus in high school, but, you know, there's prerequisites, right? You got to have like algebra 2, trigonometry, and geometry before you have calculus, right? So just think about, you know, what you need, you know, basic algebra, this, that, and the other. And I didn't really know any of that until really I got to Howard in terms of like calculus, and I jumped right into calculus class. I'm like, all right, it's no problem. And didn't do well, man. I mean, you know, to be frank, I didn't do well at all. I had to repeat the course, but once I repeated it, I killed it, and then I killed it from here on out. Because again, that's the foundation of everything. So I would just say to folks, don't be discouraged. You know, especially young people listening. Calculus, oh, that's too hard. I don't want to spend all that kind of time in it. You know, so what if you know if it takes a little bit extra time, you're not able to get it in high school. You know, that's ideal, right? And you know, get it when you can, get it at your speed. I mean, because you know, I mean, engineering. People take a lot of time. You know, if that's your passion, you spend a lot of time on it. I did 5 years. I don't regret a second. I didn't even want to leave Howard. I mean, it was fantastic. You know, I was studying and this, that, and the other, but, you know, I had to get my prerequisites straight early on, so I wasn't able to do it in 4 years. Did it in 5 years, it was all good. Then went on to graduate school and studied electrical engineering, got a master's, right? So that's coming from a guy who, you know, didn't successfully, you know, get past calculus on the first try. And then I was able to get a master's degree in electrical engineering, you know, from a top institution, UCLA. So it's not the end of the road. But if you like math, you like science, right? That's the whole thing, right? You get that as a foundation, and then the sky's the limit, right? Because the first couple of years, you know, even if you don't decide on which discipline within engineering, right, you get that foundation of math and science and differential equations, all that hard stuff they say, right? Then you figure out, you know, for those last couple of years where you want to zero in on, and you make it happen. But at the end of the day, I mean, if I could summarize it, it's all about just mathematics and science, because that's the underpinnings of anything design related, right? And
now this is really important, and it brings me to an education question. And this is kind of give me your opinion, because you know we educated brothers, and we like to educate as well. And I work with kids with my Young Producers program, and I talk to young individuals. And one of the biggest areas where urban public school kids are lacking is that science and mathematics. So looking at, you know, the future and how heavy and important science and mathematics are going to be, and you're in that field, what advice, you know, could you give me that I could possibly give to that generation, the next student? Because if like I said, if 75%, 80% of the jobs are math and science, and we're failing in that math and science, you know, what can we do? Yeah. Aside from, is there ways to go around? You not go around math, but if somebody's not good in math, are there some other, should I say, mechanisms or defenses they can utilize to strengthen that math skill for an engineering occupation?
Yeah, you know, I just say, you know, for folks that struggle with that, you know, take advantage of other people that have gone through it. Mm-hmm. You know what I mean?
Can you repeat that, brother?
Yeah, I mean, take advantage of other folks, right? I mean, you know, just like what we're doing right here. You know, I was so happy you asked me to come on the show, right? Just to give people different perspectives. Things are challenging. I mean, anything worth having is not going to be, you know, a walk in the park, right? You know, and I think that's one of the problems, you know, a lot of young people, you know, have. Everything's going to be easy, fast money, this, that, and the other. But in order to get something meaningful, it's going to take some hard work. But you know what? It's going to feel fantastic once you know, get by it. So when you hit that brick wall, right, instead of trying to break through that brick wall by yourself, you know, reach out to a community of folks that are going through the same thing, you know, and talk about it and get different ideas and talk to, you know, older people. You know, I mean, you know, different tutors, if you will, can give you different suggestions on how to, you know, get through a particular problem that you're working on. And I had, you know, for me, studying, you know, we always studied in groups, right? Study groups at, back at Howard.
I remember those.
And engineering, you know, we was always hanging out together because it was, by yourself, it just seemed so overwhelming.
Right.
You know what I mean? But when you're sitting at a table with your crew, you know, and typically it was 4 or 5 of us all the time. You know, we all did our thing, and someone had a problem with something, you know, somebody get on the whiteboard, all right, let's try to explain this thing. You know, we're acting silly, got music on real low in the background. You know, we're having fun at the same time, making dinner breaks. We made it fun. But when someone went up there, 9 times out of 10, the other people at the table, they didn't know what was going on either.
Exactly.
But there was one person maybe in the room that, oh, you know what, I think I understand that. Boom, let's get it, bam, 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 bam. But then everybody kind of gets on that same page. So, you know, the message there is, you know, use your network, right?
That's right.
I mean, the internet's there now, right? I mean, there's all types of techniques and study aids and guides. You know, you have to be a little diligent and not expect stuff to just fall into your plate. And more importantly, you know, when you hit that brick wall, you know, because you will hit it, right? I mean, engineering is hard for a reason because you know, if you mess something up in the real world, the consequences, you know, could be catastrophic, right? And we talked about the Army Corps of Engineers down at the levees. They broke, you know, the design of those. I mean, there's some other things going on there, but that's an example of if you don't know what you're doing, right, it could be catastrophic, right? So it's hard for a reason, and, you know, but it's not impossible. You get your network together, people run things off of each other, and at the end of the day, you know, people have done it. I mean, you know what I mean?
Essentially. Now, I want you to give me... one of your most as an engineer, one of the most memorable, most challenging, I should say, most challenging and memorable and or rewarding experiences as an engineer in your career.
Well,
give me the most, 'cause I know you probably got a few, but give me one of the most challenging and the most rewarding at the end of it.
The most challenging, the most rewarding. You know, I'm going to say just passing this class called electromagnetics, man.
Electromagnetics.
It's crazy.
I sound like
I still don't know what's going on with electromagnetics, man. But, you know, I kind of, you know, made my way through it, man. But that was one of the most, for me at least, you know. It's like, yeah, what are we doing, man? It's all abstract. You know what I mean? You can't really pinpoint what's going on. And, you know, at the end of the day, you start to get it. And, you know, I credit Howard, though, because I had a really cool Dr. Richardson. You know, I remember... you know, he tried to, you know, simplify it as much as possible. But let me tell you, something like electromagnetic, you can't simplify it.
Yeah, right.
It's just crazy.
The name's not simple, so the definition
out of
is
control.
surely not going to be.
You know what I mean? Yeah, so, you know, it depended on, you know, your background in science, which, again, math and science. It's back to math and science. You get, I mean, you can't even think about trying to understand electromagnetics if you don't have a background, you know, in math and science. But, you know, so that was probably the most challenging. If you talk to any electrical engineering, you know, student, you know, if you come down the hill back at Howard, it's like, yeah, EMAG. We used to call it EMAG. You know, we got nerds, right? We just nerds down there, and that's what we would talk about, man. And it was difficult in passing that class because you felt like once you passed electromagnetics, it's like you was good. You know, you felt like, okay, I can get an electrical engineering degree because I passed the hardest course that they have to offer, right? So for me, you know, that's what I could attribute to being the most challenging, the most satisfying, in my education within the field.
So in 30 seconds, one last bit of advice to anybody that's aspiring to be an engineer, regardless of what discipline they want to get into.
Right. Advice, I mean, I guess it depends on where you're coming from. If you're a younger kid, I'd say, hone in on the math and science, right? I mean, we can't stress that enough. If you're a little older, it's still not over, right? I mean,
That's right.
Leverage your network and learn your math and science, and look at which discipline that may be applicable to you. There's shortcuts these days, right? You don't have to go to a 4-year institution and spend 4 years in order to get to the electrical engineering field. I mean, there's things like data networking that with a little bit of study for a year, you can get your feet wet and start it off from there, right? So I just say if anybody aspires to do that, be an engineer or be in that that technical field, if you will, find that little niche and study, get a certification, and leverage your network when you run into that brick wall. It's the most important thing, and that goes for anything, really.
No question.
And take it from there, man.
No
take
question.
it from there. So,
Brother Clarence, as always, I want to bring you information. I want to empower you. I want to educate you. I want to enlighten you. I want to inspire you and motivate you. If you're in engineering or you're aspiring to be in engineering, hopefully you've learned something of value from here. But the Clarence Nurse's information, his email will be at the end of the show. If you want to reach out, maybe get just some other words of advice, I'm sure, and when his schedule opens, he can work with you or help you or give you some direction. That's what we do at the Urban Wall Street Project. If you missed this, check it out on urbanwallstreet.tv. As I always say in closing, be prosperous, be mindful, keep your head up. Until next time,